All right, thank you everyone. Thanks everyone here in the room. Thank you for your patience. Those of you on the webinar, thanks for joining us. We're going to kick this off. Today we're talking about landscapes for bioretention. My name is Melanie Mills. I'm a landscape architect with Canon. I have also been working with Darla Inglis from the Low Impact Development Initiative since 2009, providing technical support. And you'll find we've developed a number of presentations like this that focus specifically on bioretention and the engineering aspects of that, and you can find those on LEDI's website. But today we're really going to focus on the landscape. So first, kicking off with what is low impact development? Well, definition is a stormwater management approach that mimics nature by capturing, treating, and infiltrating runoff on site. And so some examples of LID are things like rain gardens, permeable pavement, bioretention swales. And LID is also a strategy for development where you're protecting existing landscape areas and trees for the services that they provide. You're reducing total impervious in a site design, and you're also strategically laying out your site to respond to the existing drainage patterns and the grades, and also any geotechnical investigations that are being done. So LID site design, the way that it differs from conventional site design is in that it uses small-scale decentralized stormwater management features, and it distributes those across a project site. So they're picking up stormwater at the source rather than piping everything to a larger basin, more conventional approach. So why do we do LID? Well, one reason is because it's required now. So post-construction stormwater management requirements are developed to address the impacts of development on watersheds, and they incorporate LID. And so oftentimes new projects, whether they're development or redevelopment, will actually be required to incorporate LID. So today we're going to focus in on bioretention and the landscape. And so bioretention is really one of the most commonly used LID approaches in meeting the requirements of post-construction stormwater requirements. And what are they? Well, bioretention facilities are basically high-performance landscapes. They're designed to capture and treat, to infiltrate stormwater, to retain stormwater, and they're distributed across the site. So there are a couple different ways that engineers will design bioretention systems. You'll see a slope-sided design, like this image on the left, or a planter box design. Whoops, excuse me. So the slope-sided design, these are used for rain gardens, for linear bioretention swales, and the way that they're different is that they have slopes on the sides. And what this means is that the edge transition between the ponding area and whatever condition is on the edge, whether that be a road or a sidewalk, that's made up with the slope of the landscape. And as a result, that means it needs to be wider. It means that it doesn't have to have quite as much infrastructure on the edges. It also means that the landscape condition is changing. You have one area that's ponding and one area that's dry on the side slopes. A flat bottom bioretention system, these are nice in urban areas, in tight constrained areas, because they don't need to be quite as wide. You don't have that gentle slope on the sides. But the flip side of that is it requires a lot more structure at the edges, more infrastructure. They're more expensive. They're more obvious in the landscape. You also need to make sure that you have considered your pedestrian interactions. So you've got edge conditions with a curb to keep people from tripping. The result of this is there's just one landscape condition. There's ponding all the way across it. So when you start thinking about choosing plants as a landscape architect for this, there's really just one condition to consider. So we've broken this discussion today into 3 areas: design and construction and maintenance. And so I'm going to talk a little bit about design. I first want to say that it is absolutely critical for the success of these types of systems that all of the designers involved are coordinating with one another. So from the geotechnical engineer who is doing investigations to help understand where on a site bioretention will best work, to the civil engineer who's designing the entire layout of the site and the details for these features, the landscape architect, obviously, sometimes the building architect. Everyone needs to work together. The major elements of the systems are the design of the facility, the dimensions of it, the infrastructure pieces, like the edges, the walls, the curbs, the drain, the materials that are used in the system, and then the landscape. So we'll talk about each one of these, but I'm going to really focus in on the pieces that are that have the most overlap with landscape. So okay, it's driven by the post-construction requirements. The civil engineer needs to design to those. They are identifying what kind of capacity their system needs. They're showing these on plans and in details, defining the ponding elevation, and that's delineating the landscape. So this has to be coordinated. So the infrastructure pieces are the walls, the curbs, the inlets and the outlets, check dams, and sometimes when you've got a conveyance under a sidewalk, there might be a graded sidewalk under drain. The pieces that are most related to the landscape then are elements like the check dams. So you'll have check dams to whenever you have longitudinal slope in a facility. So even if it was a rain garden, you might separate that into 2 elevations to get the best amount of ponding to create bathtubs. That's shown on the civil plans, but sometimes it's a design element, and it's something that's really coordinated with the landscape architect. Also, at any point where you have stormwater overtopping a check dam, you're going to have energy dissipating cobble on the other end. And that's an area that needs to be coordinated with the landscape plans. And I'll talk about that in more detail when I get into the materials. The energy dissipation features, these are another piece of the infrastructure that has quite a bit of overlap for landscape. So at your inlets, your check dams, culverts, any place that there's concentrated flow, you will need some sort of energy dissipation feature. Sometimes these are concrete, sometimes they're decorative. They are typically shown on the civil plans. But again, they really need to be coordinated with the landscape because the planting at those locations needs to allow for water to come in. You've got a lot of considerations that relate to the landscape. So materials in the systems, you have special aggregates in bioretention systems, and you have a special soil media. The aggregates are the drainage layer. Some bioretention systems have an additional drainage layer under the soil media. Some do not. And then there's also cobble that occurs at these energy dissipation points. So this aggregate storage layer, and this is an important one to consider if you're designing a landscape that does have bioretention systems. If you look at the image on the left, the detail on the left, you can see 18 inches of bioretention soil media, and then beneath that is a drainage layer, an aggregate layer. Well, if you're planting trees in a slope-sided system, you can't exactly come in with a good-sized tree and plant it in 18 inches of soil. You're going to hit that aggregate layer. And you don't want to discover that during construction. You want this to be coordinated. So in the drawings, you need to show this coordination at the tree planting locations. We have an extra deep section of planting soil where the trees are located. So it's as simple as that, but it's just the kind of detail that you need to consider when you're working on these projects. They look like a regular landscape, but there are many ways that they differ. Aggregate at the energy dissipation areas. This is one that I've seen in reviewing projects as a very common area where there's either a lack of coordination or maybe the traditional landscape materials get confused with the materials that are special to bioretention. So you have this cobble located at the inlets for energy dissipation. It's coordinated with the civil. It probably is even shown on the civil plans, although I've seen it shown on landscape plans as well. It needs to be significant. It needs to be a 3 to 6 inch cobble. We recently had a project hit by what's been estimated to be as much as a 100-year storm, and 3 to 6 inch cobble moved. And so if I've seen situations where a landscape plan showed river rock cobble, and it was a 1 to 2 inch cobble. If that was used for energy dissipation in a bioretention system that was hit by a large storm, it's gone. So we really need to make sure that we're not confusing the materials. Also, oftentimes you'll see projects where aggregate, like the cobble, is used in a decorative way. And this is something that I would really discourage. The plants, when they're established, will shade out weeds. They'll fill in, they'll shade out weeds. If you have large expanses of cobble in a system that might have sediment coming from upstream and filling the system, it needs to be maintained. That sediment will fill into large cobble areas, and if they're not required for energy dissipation, they're just there for decorative purposes, they'll soon be filled with weeds. The weeds will establish in that sediment, and it'll become a bigger maintenance issue than if you had plants. The bioretention soil mix is a special specification. There are a couple that are available on the Low Impact Development Initiative website, and we have information in this PowerPoint that will direct you there. The BASMA spec that's been used across the state for many, many years uses approximately 60 to 70% concrete sand with a 30 to 40% compost mix. There's a new memo on the LEDI website with a new specification that proposes a 65% concrete, 20% sandy loam, 15% compost mix. So there are some different options, and this is one of those areas that still needs further research, especially for our arid climate. And when you consider planting in 60 to 70% concrete sand in such an arid environment, there might not be enough moisture retention for plants. So this is under discussion across the field. One thing very important about bioretention soil is that in a bioretention system, that's the only soil that should be there. You can see an example here from a project that shows a depth of bioretention soil, and then over that is a depth of planting soil in that section. So planting soil could be almost anything, and it could have a lot of clay in it too, depending upon where it comes from. So you could potentially be reducing the infiltration rates from what was designed for the project and changing everything about the functionality of that project. This can happen at a contractor level too. This is happening at a detail level, and it's just something that is a mistake, but it can also happen in the field where a contractor might think that a depressed area in the landscape should be filled in before it's planted. So there are different places where these things can show up. So the landscape component of bioretention, consisting of irrigation and then the whole planting side. First touch on irrigation. So this is becoming more and more of a hot topic. It used to be that people were concerned about bioretention because, well, don't all those plants want tons of water? Well, they don't all want tons of water, and especially if you have a really drought-tolerant bioretention list, which LEDI does have online. So that's less of an issue, but even as the drought is more and more severe, the idea of application rates, of establishing, of even having irrigation. So I will say that I think irrigation is important. I think it's important to establish plants in a bioretention system. It's a functional system. It's doing more than it's not just an aesthetic system. And so it's important to establish the plants. The roots will develop way better through an establishment period, 1 or 2 years. Then in the first year that they're exposed to storms, they're going to be able to hold soils better if you've established them with irrigation. If they're struggling, they haven't had irrigation, maybe they got hit a few times with a water truck and then they got the rain, they might not be able to stabilize soils to the degree that we would like. You can consider permanent or temporary irrigation systems. If you're looking at bioretention in an urban area, in a shopping center, for example, or a residential area, you might want to consider a permanent system so that you can water those plants in future extreme drought or high temperature conditions to keep them looking decent. In an open space area on the edge, you might go for more of a native approach, and over time you just let that irrigation system go. Just matters if you're accepting a really dry look, so that part is up to the project manager and the designer to figure out. So people talk about not having irrigation, and especially as budgets are tightened in municipalities, this starts to look like a good option to people. And what I'll say about it is that if you go without irrigation, you're going to have perfect timing. You're going to have to plant those plants at just the right time. The weather's going to have to really work for you. You're going to have rain when you need rain. You're going to maybe have really good neighbors. This is an example here of a project with no irrigation, and the upper image has good neighbors, and just down the street, and I shouldn't say they're bad neighbors, but they didn't choose to water the public right-of-way, and I think that is understandable. So that is a good segue into the next item, which is you better use native plants, because all the plants that survive that aren't weeds in that upper shot, they're all native plants. And some of them did make it. The other option is to have a water truck and to have a warranty period from the contractor where they'll be watering those plants to get them established. And type of irrigation, and this one's interesting too, and I feel like I've learned from our recent project in Paso Robles on this one. So microspray or drip irrigation, what should you use? We chose microspray on this project mostly because of how sturdy it is, as opposed to drip irrigation. There was concern and some complaints by neighbors about us not using drip irrigation on this project. But it's interesting when the project was hit by an extremely large storm in the summer when it wasn't expected, a lot of sediment entered the bioretention areas, and they'll have to be removed. They'll have to be removed manually, but with shovels. They're going to be in there walking all over that place. And I'm so thankful that it isn't a drip system, because I can't imagine the kind of damage that would have been done. And then you're either seeing leaks down the road that are wasting more water, or the municipalities having to repair a system. So I think that's been a good lesson learned for me. Bioretention areas are high performance landscapes. Yes, they are providing stormwater, water quality function, but they're also, plants are providing aesthetic value, habitat value in some cases, yes, treatment. Trees and plants can do traffic calming, air pollution, they can sequester carbon. The more plants we have and trees we have, we can reduce our heat island effect. So there are a lot of benefits that come out of bioretention systems. And when you use native plants, you're just maximizing that because that's where you can get the habitat, the reduced water use, and the longevity and potential for greater success of the plant material. So plant selection, there are a lot of resources on the LEDI website. You'll find a plant list that has been culled down to a pretty small list of strong performing plants that do well in our area. There are also plants on this list that will do well in other parts of California. Some of the really great performers like the Juncus patens that's shown right there. LEDI has a lot of plant resources on the website. This is an example. I'm going to flip through these. We worked with Randy Gunder, who is a recent graduate of horticulture program at Cal Poly. She's also a graphic designer, which was wonderful. And she helped to create a whole series of plant palettes for different applications of bioretention. So the first application being residential. So she put together a basic design and a showy design. And I would just point out that in these, you can see the ponding zone, that's the zone A. That's the area where plant selection is specialized to bioretention. Zone B, designers can really choose what they want. So if you're on the upper side slopes of your rain garden, as long as the plant will tolerate the sandy conditions of the bioretention soil, it's really up to the designer based on the project. It's that zone A down in the bottom that's much more specific to the function. So these plant palettes that Randy worked on provide also applications for urban and commercial projects with, again, a basic design and a showy design, one that uses a planter box design. So these are really a nice resource if you just wanted some sample plants that you could put into a project. There's also a third application type, and that's rural. So this would be like a bioretention swale along a rural road. And this is such a low maintenance palette that it could potentially be established with a water truck at the right time, just native plants, and it could even be mowed. It's just such a simple palette. So trees and bioretention, traditionally mostly on the side slopes where they're not really having ponding at the base of the tree, at the trunk of the tree. You also see them in planters. Sometimes you'll see them planted in the bottom of a planter. Oftentimes they'll be mounded like the upper right image. And then sometimes they're just completely separated. They might be in a tree box and then a bioretention planter would be adjacent. This is another area that really requires further research for California to try to fine-tune the tree list that will work in ponded conditions in our arid environment. Landscape, another element is the mulch, and it's just important that mulch is properly specified. You don't want floating bark mulch in bioretention systems. Oftentimes we'll just use a compost for the mulch. It doesn't wash out and clog the overflow drains. Another approach is to just mulch above the ponding area, so on the side slopes of a sloped system. And then you don't want to put mulch down right before the rainy season. Plans and specs are critical. These projects, these landscapes, they look just like a landscape, but they're different. And so sometimes we need to provide additional information to move from design into construction. So one thing that we found works really well is to provide an additional exhibit for the contractor that identifies on the site all of the areas that are bioretention, regular landscape. If you have different landscape types, to give them a simple graphic that outlines those, and then in the specification to provide an explanation for each of those and how they differ in the spec. So they can go back and forth. It really helps them to better understand the work that they need to do in the different types of landscapes. Also, terminology being consistent is very important. So probably one of the biggest areas of confusion that I've seen in reviewing LID project documents for the Low Impact Development Initiative is the coordination between the bioretention details and specifications on the landscape side and the landscape designer's boilerplate specs. So this is where you start to see they might plug in their normal landscape spec into the document, but they haven't incorporated the bioretention piece. They're still calling out for a certain treatment in the landscape and not pulling that out of the bioretention areas, if that makes sense. So you really need to be focusing on soil prep details and all the different sections of the landscape spec. You know, topsoil amendments, it's different between these two systems. Finish grades are different. Use of fertilizer, the type of mulch you use, all these things are different. And so you need to make sure you go through, the first time you do it, it takes a long time. But from then on, it looks pretty good. Bioretention soil media, as I mentioned, there's a spec for that, and it needs to be coordinated with those sections. So construction, again, these projects can look very similar to a conventional project. So just communicating this to the contractor is critical. I think the best way to do this is to have a required pre-bid meeting for public projects and to have pre-construction meetings with the contractors as well. So you just go in, you explain all the differences of these projects and get them on board early so they understand it, so they bid it right too, so they don't find themselves losing money and trying to cut corners on the project. Elevations, super critical aspect of construction that has applications for the landscape. All of these different elevations, the gutter, the finished elevation in the facility, the overflow, those can be sometimes altered by a contractor. They might not be implemented and constructed as they're shown on the plan because the contractor doesn't understand it. These are just some examples that they could have been incorrect in the design elevations in the drawings, but they might have also been changed during construction. The example on the right shows a bioretention bulb out in a parking lot, and you can see it's got this intentional curb cut, but the entire elevation of the planter is up at curb elevation like a traditional landscape. So they must have figured this out and then rock lined the area where the water comes in. So really they're getting virtually no functionality out of this, and this may have been designed as a requirement. So these are things you need to consider, make sure that the contractors understand. Who does what and when? It's different on these projects. The main contractor on the project is going to install the aggregate. They might install the bioretention soil media as well. Had an example on a project where they graded the thing out beautifully. Well, then the landscape contractor needs to install the irrigation. So what do they have to do? They have to go into this perfectly graded landscape and trench it all out and put the irrigation in. So these are things that if they knew about this in advance, they might be able to coordinate better. There are just special aspects of working in bioretention soil that it's important to communicate. You want to make sure they're delivering what they say to the project because it is functioning. You want them to understand what's expected of the compaction for the installation. Mixing the soil types is something you want to avoid. If you've got a landscape area next to a bioretention area, they're going to have different soil prep. You're going to till in and add some compost to the landscape next door, adjacent, But the bioretention section needs to just be bioretention. So you don't want the contractor going in and amending the soil on the adjacent landscape and dumping that into the bioretention soil, because it could potentially, depending on the soil type, it could clog it. They also need to know they can't work in wet soils. That can over-compact the system. So when you get to the landscape and the construction, it's just so important to emphasize with the contractor that the grades on the civil plans are what needs to show at the end of their landscape installation. So landscape contractors are not always accustomed to having to grade to such a fine level, and they need to consider how much mulch. You don't want them to finish grade and then not have enough elevation to fill in with the specified mulch. You want them to think this through ahead of time, excavate out to the correct levels so they can fit all of the different materials that are in the section, and avoid tripping hazards and issues at the end of the project. Another piece of the landscape side is plant establishment, and just keeping in mind that you need to let these plants root before you can open the systems up. So this is a good example, a photo example of a system that has sandbags in place until it's ready to go online. Maintenance. Maintenance is one of those things that we don't like to really think about early on, but it's, again, these are special systems. They're doing more than a traditional landscape, so we need to recognize they may need some extra maintenance. We need to communicate that to our client. Client needs to know up front they're going to have to do more for these projects. It's whenever possible, it's great to have a 1-year warranty with your landscape contractor, and to ensure that the plants get established and are cared for during that year. It's also important that the designer is on for the construction administration piece, so that they can monitor this warranty period, they can monitor the proper construction, and then they can hit that punch list at the end and make sure that the client gets all the plants that they paid for and that the system's ready and working after a year. So whenever possible, that's a great way to go. That way you're filling in missing plants. If the mulch coverage is not complete, if the irrigation's not working, you can catch these things during that 1-year warranty and have them repaired. So the client gets a perfect project when they hand it over. So back to the irrigation piece, the drought tolerant approach, you've got a year, 2 years, 3 years of establishment, and then you can, if you've got native plants in there, you can go to reduced watering except during extreme conditions. One thing that's important to know about are the application rates, because the soils are so free draining, and in a system where you have an underdrain, a perforated pipe underdrain, it's important that you're not overwatering and the water's actually running off out of your system through the underdrain. So some guidance that you want to provide to your client, to managers of a project, how it's different to maintain bioretention areas. They need to be aware of the sediment removal, the debris removal. This has to happen regularly so that you don't get a clogged system. Repairing changes to grades that might happen through maintenance. Relocating or removing plants that start to grow and maybe block an inlet or an outlet. And then when you have plants failing, getting those replaced. So ideally, you can develop some sort of a maintenance plan for your client, or you can seek out an existing maintenance plan that will help to provide guidance to the crews, because the systems may look similar, but they have really different needs, and that needs to be communicated to the crews, just like it does to the construction crews. This is an example of a maintenance plan that we developed. Those plans should ideally have an annual schedule as well as checklists that are regular checklists, say a monthly checklist, but then post-storm, pre-rainy season, and post-rainy season are the times that you would want to have an additional checklist. And again, this is a maintenance plan that we developed. So big picture on the design front, you want to be as clear as possible. You want to point out how these projects are different in your design. You want to coordinate your documents with boilerplate documents you might have used on traditional projects. You want to coordinate with the other disciplines. On construction, it's just so critical to have this deliberate transition between all the work you've done as a designer and the construction phase. So those pre-bid and pre-construction meetings are critical. And then just clear communication to define how these are different. And whenever possible, the designers being involved in the construction administration. And on the maintenance side, planning for operations and maintenance, being really honest with your client about the level of maintenance that will be required to take care of these systems and have them function properly. And then potentially developing documentation for your client on this. Also, including the maintenance staff, whenever possible, we like to get maintenance involved very early on in the design process so that they're feeding into us the reality of the systems that they have in place, the crews they have, so that we can design appropriately for, say, a municipality's expected level of maintenance. So there are a lot of resources that you can find on the Central Coast Low Impact Development Initiative website. This is what the site looks like. There's training information, all sorts of details. There are technical assistance memos, TAMs, on bioretention, vegetation, construction. These are what they look like. All sorts of CAD details, and then the plant palettes as well. We also have video recordings, just like the one we've done today, on bioretention construction, on all aspects of bioretention design, on permeable pavement. So all these resources are available if you'd like to spend a lunch watching one of these another day. And that is it for today's webinar. So thank you everyone for joining us here at Canon, and for all of you on the webinar, thank you so much.